Hello, children. Wish you a very good day. Now, after a quite long time, we are meeting again with the Infinity Geometry Result Uplifting Program. Now, today, I have selected a very good question from a grade 10 paper. I think it's Nalanda. Let's go to that. Uh, there you go. Now it will appear. I think it's there. So this is the question. Yeah, it's Nalanda. So this grade 10. They say a revelation test. Something regarding the term test, I think. So now let's see this one. Here we want. Here we want to do a construction, a little bit of a drawing. A drawing construction should be done regarding this question. This is a geometry question. Now see how it works. Okay, let's go to the question. In the triangle ABC, D and E are midpoints of AB and AC respectively. A line drawn parallel to AB through C meets produced DE at F. Now, before we draw the actual figure, you just draw a figure apart and see how it looks like. So this is what they say basically. These two are parallel. So these are the midpoints. That means this and this equal, this and this equal. Yeah, that's all. That's all what they say. So now we will draw the actual figure, enlarged form of that. We will draw with like this. ABC triangle. In the meanwhile, you pause the video and draw it. You pause the video and draw it. Then AB as a line parallel to this AB through going through C. Let's say it is going like this. Like that. Now, okay. And also, we came across a line like this also. Right, then we will name them. This will be A, B, C, then D and E according to my figure. D and E, then is there F? Sorry, this is E, this is F. Okay, so then this is equal to this, this is equal to this. So these two are parallel. AB and CF are parallel. Then we can say that this is now here alternate angle. I can see this one and this one alternate. I can see. Then this another Z I can see another alternate. This and this and this, another alternate, and these three are, sorry, this couple of angles, this pair is vertically opposite, so they are also equal. So they first ask, represent the above information in the diagram, that's okay. Now that one also carries marks, so remember that even if you keep the question unanswered, even, only after drawing, that will also carry some marks. Right. Then show that ADE triangle and CEF triangle are congruent. ADE and CEF. Now see the cases, possible cases. Now this side AE and EC are equal because of what? Because they are E is the midpoint. They have given that E is the midpoint. And ADE angle and EFC angle are equal because of alternate angles. Then AED angle and CEF angle are equal because of vertically opposite angle. So that's very easy. That's a very easy question. Second part is a very easy question. In triangle AD, specifically AD, in triangle AD and triangle CEF, we can say ADE equal EFC. Then DEA equal CEF. Now this is because of vertically opposite. This is vertically opposite. This is alternate. Okay. Then AE equal EC. AE equal EC because E is the midpoint. E is the midpoint. So therefore, now we can say angle side case. Therefore, we can say therefore right. Okay, you can see this. Now, so we can say therefore triangle ADE is congruent to triangle. What is the triangle they wanted? CEF. CEF and angle side. So that's it. That's the first part. So now we can go to the second part. Okay. Now we will go to the second part. That is show that BD equal CF. BD equal CF. Now is it Is it correct? Is BD equal to CF? If so, how is it equal? If so, how? Hmm? Right. Now I got it. Now here, you can say AD equals CF because of corresponding sides of congruent triangles. And also AD equal DB. AD equal DB because D is the midpoint. So by axiom, I know if AD equals CF and AD equal BD, by axiom BD equals CF. By axiom BD equals CF. So let's write that for Roman 2 we will go. For Roman 2 I can write AD equals CF. First point. AD equal CF. Corresponding sides of congruent triangles. Then AD equals CF. AD equal DB. AD equal DB. AD equal DB because of D is the midpoint. D is the midpoint. Then by axiom I can say, therefore DB equals CF. Therefore DB equals CF by axiom. By axiom. That's it. Roman 2 done. Okay. Roman 2 done. Roman 3 2 done. 3 done. This is actually Roman 3. This is Roman 2. Okay. Then prove that BCFD is a parallelogram. How come that? We choose yellow color, so green color. BCFD is BCFD a parallelogram? Yes, because there's a theorem. A quadrilateral can be proved a parallelogram if one pair of opposite sides is equal and parallel. But what is that theorem? If one pair of opposite sides is equal and parallel, a quadrilateral can be proved a parallelogram. Now see that we proved BD equals CF just a second ago, you know. BD equals CF. And also BD is parallel to CF, right? But it's given. It is given. Yeah, my bad, I haven't marked it. Right. Then BD equals CF. So you can write in Roman 4. BD equal CF proved earlier by axiom, proved earlier. Here we have proved that. So BD is parallel to CF, given, that's a data, that's a given one. So therefore, what is that? A BCFD is a parallelogram. Therefore, BCFD is a parallelogram. You can write the reason. One pair of opposite sides is equal and parallel. One pair of opposite sides is equal and parallel. Okay. So that is also done. Roman 4 done. Now Roman 5. Roman 5 last part. DE equal half BC. DE equal half BC. Then right. Then what to do? Now what to do? Now now this is what? Now pause this video and think for a moment. What can you do to prove that? DE equal half BC. Now again, it is coming from axioms, I think. Now see what I am going to do. I will say this one. I will say DE equal EF. You will agree. DE equal EF, you know, because corresponding sides of congruent triangles. DE equal EF. It's the last part. DE equal EF corresponding sides of congruent triangles. Okay, then now BC equal DF. BC equal DF because opposite sides of a parallelogram are equal. You know that. Opposite sides of a parallelogram. Now in the school, by now you should have done this lesson, parallelogram lesson. I think now by now you would be doing some lesson around logarithm. Logarithm also you would have done. Now we will do a logarithm summary in the future. BC equal D, BC, sorry, what did I write? BC equal DF. BC equal DF because opposite sides of parallelogram. So now I can write, now I want DE, you know. Now DE and BC. So I write BC equal DF and DF is equal to DE plus EF. DF, BC equal DF and DF equal to DE plus EF. DE plus EF. So I can write now as therefore by axiom BC equal DE plus EF by axiom. I can write that, you know. Right. And also EF equal DE. EF equal DE. So therefore I can write BC equal DE plus, instead of EF also I can write another DE. Instead of EF I can write another DE. So that will be 2DE. So BC equal 2DE, which means divide both the sides by 2. DE equal half BC, or BC divide by 2. So then therefore we'll say DE equal half BC. So if you are a grade 11 student watching this video, you will do the last part easily by the theorem, the midpoint theorem. But since this video is for grade 10 students, grade 10 students do not know about midpoint theorem yet. So therefore, they have to go from this method, right? So first one, drawing the diagram. Second one, congruency. Third one, axiom. Fourth one, parallelogram equation. Fifth one, again axiom. So see how many lessons are included in one geometric equation, right? So not an easy task. It is neither difficult nor easy. I would rather say like that. Neither difficult nor easy. Maths is not difficult but different. Rather, we go with the word difficult. I don't like that. I want everyone to be familiar with these geometric equations, which most of the students are struggling with. Right, okay. Then pause the video and try each and every step again before looking at my answer and doing. Then if you fail to answer the questions, you can proceed with the video and see the answer. Okay, children, then practice well. We will see soon in another video. Stay safe until that. Goodbye.